Given question, a torque of 300 Newton meter acts on brake drum. If the angle of contact in between brake band and brake drum is 250 degree and mu is equal to 0.3, determine applied force P at the end of brake lever for the position shown in the diagram.
Let us understand given data with the help of diagram. Angle of contact in between brake band and brake drum is given 250 degree, and we have to take this angle in terms of radians. So we will take 250 into pi by 180 radians. Then the radius of the brake drum is given 250 millimeter. Torque is also given, which is applied on this system. It is 300 Newton meter. Now if we observe the direction of torque in the diagram, it is given in clockwise direction, and the coefficient of friction in between the brake band and brake drum is given 0.3. We have to find out applied force P on the lever. Now if we observe the diagram, here the brake band is connected in between brake drum and lever, and we have to decide the tension. That is, first we have to decide the tight side and slack side, because this is the question of rope friction. So how to decide? Now we know that this brake band is extensible, so tension created is in the outward direction from the brake drum as well as from the lever. So we will first show the direction of this tension. So from this brake drum we will show outward direction for this tension, and from this lever we have to show outward direction of this tension. Now how to decide the tight side as well as slack side? So we know that the tight side is equal to T2 and slack side is equal to T1, and T2 is greater than T1. Now if we observe, this part of lever is the fixed part, and here the angle made by the brake band with this part is 90 degree. It is also given. Now this part of the lever is pivoted about point O and it is rotated about this point O, and we have to find out the applied force P. So we can say that if this part is fixed part and motion is in the clockwise direction, and because this part is fixed part, so we can say that this is the tight side. So here we can write tension T2, and this side is the slack side, and here is the tension T1. Now in the diagram given, because this is the fixed part, here the normal reaction R, which is perpendicular to the surface of the fixed part, is also given. Now we have to draw the free body diagram. So we will first take this brake drum and then we will draw this lever to draw the free body diagram. Now for this brake drum we have to show tension T2 and T1. So I will show here is T2 and here is T1, and we have to also show the direction of the torque, that is in clockwise direction. Now we will move to the lever. So for lever, this is the fixed part, here is the part O. So here 90 degree angle is made, and here is the tension T2. So we have to show this end. Then here is the tension T1. So we have to show here the tension T1. And then the force P. So we have to show this force P in the upward direction. We have to also show this reaction R, which is mentioned in the question. So here is the point O. Now this free body diagram is completed. We will calculate mu theta, which is equal to 0.3 into 250 into pi by 180, which is equal to 1.309. Now from the law of rope friction. So we know that law of rope friction, T2 is equal to T1 e raised to mu theta. So we will directly put this value and we will calculate. Now we will get the relation in between T2 and T1. So I will underline this. T2 is equal to 3.7 T1. Now we will move for the torque. So how we can define this torque, and it is given in Newton meter. So torque is equal to effective force multiplied by radius. Now if we observe the torque on this brake drum, then this torque is given with 300 into 10 raised to 3 Newton millimeter. So I will write here, because radius is mentioned in millimeter. So I will write here 300 into 10 raised to 3 Newton millimeter. And here radius R is given 250 millimeter. Now from this diagram we can define this torque is equal to effective force, because here T2 is greater than T1. So we have to write the effective force, that is the difference in between these two forces, that is T2 minus T1 multiplied by R, which is equal to 300 into 10 raised to 3. So if we put this value of T2 in terms of T1, that is 3.7 T1 minus T1, that is we have to replace this T2. Then we will get here T1 into 2.7 into 250, then only one unknown term, that is T1, and T1 is equal to 444 Newton. And from this value of T1, if we put here, then we will get T2 1644 Newton. Now we will get these two values, T1 and T2. We have to find out applied force P. Now we will move to the lever. Now if we observe this lever, then T2 is known, T1 is also known, but R is unknown, and P we have to find out. So how to find out? So we will consider equilibrium of this lever, and we will take the moment of all forces about this point O. So how to take the moment? Now we know that at this point O there are two forces, T1 as well as R. So when we take moment, then this T1 will become 0 as well as R, this R will also become 0. Now for the other forces, we have to take moment force multiplied by perpendicular distance. So how to consider this perpendicular distance? So we have to take line of action of force. So if I extend this, then from this point O, what is the perpendicular distance here? 50 millimeter. Now if I move the compass about this point O in the direction of T2, then here is the direction. So this is the clockwise side. Now if I move the compass in the direction of this applied force P about point O, then here is the direction. So this is the opposite direction. So either we can take here is positive, here is negative, or we can take these two moments equal. So I can write here T2 multiplied by this perpendicular distance 50 is equal to P multiplied by this perpendicular distance. If I draw here line of action, then about this point O, this is the perpendicular distance. So P multiplied by 300. So here is the equation and one unknown term P. So P is equal to 274 Newton.